In the next couple of videos, we're going to talk about some extra tricks that are going to let us solve limits that on the first glance look like they're not solvable. I mean, you're going to stick in the value and you're going to get an answer that doesn't make any sense. But by doing some tricks, we're going to be able to figure out how to turn it into a limit that does make sense. Let's take some examples of what I mean. So you see here that we've got the limit as x approaches 2 of x squared minus 3x plus 2 over x minus 2. So let's see if rule 1 works for us. Rule 1, remember, says that if we just plug in 2 for x and we get an answer, then that's our answer. So 2 squared is 4 minus 3x is minus 6 plus 2 over 2 minus 2. So 4 and 2 is 6, take away 6 is 0, and 2 minus 2 is 0. 0 over 0 is what we call an indeterminate expression, which means that it doesn't really mean anything. 0 divided by 0 could be any number at all. So we're going to have to do a little work to figure out which number it is. Another example of indeterminates is when we were doing the limits at infinity. We would get answers if we plugged infinity and kind of did the math, we would come up with infinity over infinity, which is another example of an indeterminate response. We saw that depending on what the limit was, sometimes the limit was actually 0, sometimes it was infinity or negative infinity, sometimes it was 3. Okay, so we needed to do some extra work whenever we come across one of these indeterminate responses. So what we're going to do, and this is going to remind us about our Algebra 1 time, is we're going to factor this quadratic expression. And if you need some practice with factoring quadratics, just give a shout and I'll make some extra videos about it. But I'll give you kind of the short and sweet version. What we are looking for is a pair of numbers. We're looking for two numbers that if you multiply them together, you get positive 2, and if you add them together, you get negative 3. So are there two numbers we can think of that satisfy that? The answer is yes. So 2 and 1 multiplied together give me 2. 2 and 1 added together give me positive 3, which seems like it's a dead end, but then I realized that if I take negative 1 and negative 2, they multiply together to make 2, the negatives cancel each other out, and they add together to make negative 3. So negative 2 and negative 1 are my two numbers, so I'm going to do this with it. That's where my negative 2 and negative 1 are going to be. So they become like the second term of that binomial. And I've got x minus 2 from before. Okay, so how does factoring that quadratic expression make this easier? Well, notice that I've got a term of x minus 2 and a term of x minus 2 in the denominator, so I could just cancel those out. Remember, I can cancel expressions out of the numerator and denominator as long as they're not equal to 0. But x minus 2 is only equal to 0 if x is equal to 2. And this is the limit as x approaches 2. So when I'm thinking about the limit at 2, I'm not thinking about the value at 2. I'm only thinking about the values near 2. And values near 2 that aren't 2 are not going to turn that term into 0. So this is the limit as x approaches 2 of x minus 1. And so look at this. Now I can use rule 1 on this expression. I can plug 2 into this, and I've got 2 minus 1, which is equal to 1 as my limit. All right, so look at what we did. We used factoring to take away the thing that was giving me the 0 over 0. The thing that was giving me 0 over 0 when I plugged 2 in was the fact that this x minus 2 was equal to 0 in the numerator and denominator. But I could factor them out because x is never equal to 2 when you're taking the limit at 2. And so canceling those out, I'm left with something where I can substitute in the number. Let's take another example. Let's look at the limit as x approaches 5 of x squared minus 25 over x minus 5. So once again, if we plug 5 into this expression, we're going to get 0 over 0. So that's indeterminate. And so we need to look closer. So we're going to try and factor this expression. So one way you could think about this, if you want to use the same trick we just did, is maybe I want to call that 0x minus 25. And you're looking for two numbers that multiply together to make negative 25 and add together to make 0. Another thing you can do, and this is going to be important for our next video, is we can remember this bit about the difference of two squares. If we've got something that's the difference of two squares, then that can be factored into the sum of the two numbers times the difference between the two numbers. So either way, either one of those tricks, you're going to see that that's the limit as x approaches 5 of x plus 5 times x minus 5 over x minus 5. And once again, this is a pretty thing that happens whenever you do these factoring problems. If you've got 0 over 0 in a rational function like this, you can be guaranteed that x minus 5 is going to be a factor of this. And so that's equal to the limit as x approaches 5 of x plus 5. And now I can use rule 1, substitute 5 in for x, and that gives me an answer of 10. All right, so finding limits by factoring is a powerful technique that we are going to come back to over and over the next few weeks.